Okay, my name is Tore. I'm from Norway. I'm going to tell you a story from my experience with the Reach RS. I used it on a boat to make the accuracy a little bit better. So I hope you enjoy it. This is the heading, intro to the display. It's just a page indicator to describe the progress as I go along. This is the beginning with the first Reach unit. A lot of do-it-yourself stuff and make it simple and cheap, easy. You can see the tripod with a lunchbox and a CD cover with a tin foil to make the antenna receive the data much better. There's a long story from here to the boat, so the rest of the story you can read on Emlid forum. I started with digging into the features of Reach RS and what kind of data you can output from the connectors and interface. I also investigated the backbone network in my boat to make sure the connection and interface is working. So my goal was to increase the accuracy of the boat's GPS. It's quite poor actually. Was fluctuating between 5 to 15 meters. So the experience with the inbuilt GPS in my plotter was quite poor. So I started digging into the RS feature. So I'm going to show you a bit more picture and describe a better. This is the boat I'm using. Just today that I got it, so it has no radar or plotter in it. There are some screens from the display that I used during the installation before I connected it to the Reach. You can see the radar display overlaying the short maps just to keep the safety level when I'm driving the boat in foggy weather and with a lot of clouds. And I can see other boats. I get warned when they are getting close to me. This is a down scan view, or maybe a side scan. I'm actually mixing those two up. This is the short map I'm using. That's probably a side scan similar to this one. What you're seeing here is a line with a buoy just below the surface. So I can actually touch the screen and pinpoint this target accurately. And by having the RS connected to my plotter, I can actually get a lot better accuracy for that target below the surface. So that is the gear I have installed in my boat. It's a 3G radar, similar plotter, a total scan transducer. I have the RS, two of them mounted on the side of the boat just to do a test. I think I have a display track where I'm showing the difference between the plotter GPS and the RS RTK. And I think I measured it to be 2.5 meters off the track. So keeping accurate position is crucial. This is the AT10 adapter I used to hook up to the boat's backbone. It's not displayed right here, but it's in there somewhere. And I have a screenshot with the RS connected to my plotter. I have a mounting stand back at the transom to keep the pole with the Reach RS vertical above the transducer, which is located just below. There are some issues with boats rocking around in the sea, so you have to be aware of the inaccuracy when the boats tilt too much. I have a fix for it with one of Brand's application that integrates the IMU to autocorrect for the tilting function. This is the cable I use to connect the Reach with the backbone and the adapter. In picture, I used a 1 Hertz converter. I've switched it for 10 Hertz to make the screen appear more fluent. It's the same screen with the RS showing display. My goal is to have the plotter show me a better result and more accuracy when I use the plotter to its function, like pinpointing targets, get accurate bathymetric survey below the surface. This is just to make the safety a bit better for boating experience. So I have this cat meme. I'm a fan of this. Image adjusted for the roll and pitch and yaw movements. When the boat is rocking, the transducer for bathymetric survey is not looking directly below the GPS receiver. So I have to integrate the IMU to make this working a little bit better. The transducer mounted on the transom is also fixed. So when the boat is rocking, the responding signal from the ground is actually going to deviate from the actual position. So it's important to keep the boat level and perfectly flat. Serial data is forward from the boat's predefined height below the Reach RS. Antenna based on the fuse, pitch, and roll, yaw, and position from the Raspberry Pi. This is a progress. I'm working right now with the excavator app from Brandt's mission. It's not finished yet, but it's closing in. This scenario is actually a true story that happened just a month ago or so. There was a missing sailboat who was struck by the boom in the back and fainted. He didn't have a vest, so he sunk quickly. The officials did a search for him for about a week before they closed down, and the rest of the crew is volunteers trying to find him. I'm located on a boat. We have 2 divers in the water, and there's a standby boat as a head of the search crew. The police had received information that a fisherman has picked up something suspicious in a fishing net and has given us the coordinates to try finding him. So I was driving across the position we were given. I picked up 2 distinct objects, but once I was monitoring the display, I noticed the GPS was fluctuating. So the position that I tried to pinpoint actually could be way off. And the second run, when I tried to locate it and find the position I pinpointed, I also noticed the GPS was still fluctuating. So I'm guessing between 14 to 20 meters inaccuracy when I did targeting. With the Reach RS in RTK mode, I can drop the pinpoint with centimeter accuracy. It will be much easier for the divers to accurately dive and try to find him. Those divers are free divers. They use their own oxygen, no tank. So they only have 30 seconds of air. When you get to 15 meters, the survey area is just pitch black, so you don't see anything. So you need to be accurate. So this is a true story. I hope I get this to work, because this is going to matter someday. This is the IMU integration with Brandt's excavator app. As you can see on the screen, on the top right corner, there's the input, and this coordinate you see there, that's adjusted for the IMU adjustment. So when I tilt the pole, the bottom end of the pole is always be the same coordinates, depending on the angle. this is work in progress, so we have a little bit more work before this is final. I use a Raspberry Pi to display this screen, and this is supposed to be connected to my plotter to correct the shifting of the pole when I drive the boat. That's it. Thanks for me.